Welcome to the project demonstration of health monitoring glove. So here we are going to monitor the health parameters like heartbeat and pulse oximeter data SpO2 from this MAX 30100 sensor and temperature from this LM35 sensor. These two sensors interface to Arduino NANO board. So at the pin number of A4 and A5 pins interface to this MAX 30100 and LM35 temperature sensor interface to A0 pin. So based on this calculation of the sensors data, we are going to displaying that on 16:2 LCD screen, which we have interfaced that pin number 2 to pin number 7 to this Arduino Nano board. And the whole system getting power supply from this lithium ion battery, so which is a rechargeable battery. So here the battery ratings are 3.7 volts, 2000 milliampere per hour battery rating. So this is a rechargeable, we can charge a battery from this boost converter, buck boost converter. So here the purpose of this buck boost converter is it will take 5 volts DC inputs and provide us the output of 3.7 volts to charge this battery. So once we if you want to utilize that, by switching on this, we are getting the 3.7 volts input to this boost converter and provide us the 5 volts output through this blue and green cable to the whole setup. So in order to recharge this battery, we need to connect the B-type charger at this slot as I shown. So gently press into that. So once it's inserted properly, so this light will be showing the status of the battery is charging. Once the battery is fully charged, so the light will continuously on state only. So once it's showing the on state, then you can disconnect the charging cable very gently, and now you can mount this whole system on your right hand. So coming to the flow, so here the system interfaced to this MAX 30100 at A4 A5 as it was communication through the I2C protocol. So any module which is communication through I2C protocol, we need to interface two pins, that is SDA, SCL, serial data and serial clock. So these two pins are hardwarely available on this nano board at A4, A5 only. A4 is nothing but SDA, SCL for A5 pins. So based on this data, based on the clock frequency, it will keep on sending the heart rate as well as pulse oximeter. It will be calculated based on the IR LED and red LED which is present on this sensor other side of that. And LM35, so which is provide us the temperature value in terms of analog voltage. So for example, if we get 0.37 volts from this sensor, then we need to directly multiply that with 100. So 0.37 into 100 nothing but 37 degrees centigrade. And as we know the formula to convert the degree centigrade to degree Fahrenheit, that will be done by our nano board and it will be displayed on the LCD screen. So let us see demonstration by mounting that whole system very gently, as we are we should take care of this sensitive wires which are interfaced to the input sensors on this board. So once we insert it properly to the hand, so check this particular sensor should touch our forefinger tip at this slot only, not on this line, at this slot only. We should take care of that. You can sense that. Now you can switch on the main power supply. Then initially it will be the display the welcome message, and thereafter the heart rate and the pulse oxy data will be stabilized. So once the stabilization are done, you can see the constant heart rate and pulse oxy data along with temperature. Right, now it is stabilized. Actually fluctuating from 85, 83, 87. So that is a very accurate here. We are calculating that. So if you remove the finger, then the data will be fluctuated heavily. Right. When it is showing 0, again put it on the ground to get the data. Right.